Hey, welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda, and I'm going to teach you some algebra right now. This is lesson 8.3, and in this lesson, we're going to actually manually graph a parabola using a few different points. So let's get started. As you can see, our essential question, how to find the vertex of ax squared plus bx plus c. So we've got this new thing in there now, the bx. But it's more than the vertex. There's a few things we're going to talk about here. So first off, let's talk about we talked about the parts of the parabola before, like the vertex and this line of symmetry. Let's talk about the y-intercept. Like all graphs, the y-intercept is the value of y when x equals 0. So here's our y-axis. That's where x equals 0. So whatever y is, that's where the graph is going to cross. Let's talk about the x coordinate of the vertex. X coordinate of the vertex. So this looks like some positive number. It's the value of the axis of symmetry. We talked about the parabolas being symmetric around the axis of symmetry, and this is the formula. So this is the formula you're going to have to remember. X equals the opposite of b over 2a. Okay, so that's something important to remember. And let's try this here. It says, find the axis of symmetry and the vertex of the graph of f of x equals 2x squared plus 8x minus 1. Okay, so the axis of symmetry, so the answer to A, the axis of symmetry is x equals the opposite of b over 2a. So x is going to equal the opposite of b, which is 8, over 2 times a, which is 2. Okay, in case you can't remember, this is A, this is B, and this is C. Okay, so let's simplify this here. X equals the opposite of 8 over 4, so x equals negative 2. Okay, so that's our axis of symmetry. Now the vertex is going to be on that axis of symmetry, but we need a y value to go with it. So what we do then is just find out that y is equal to, I'm going to use the original equation, but substitute negative 2 in for x. So 2 times negative 2 squared plus 8 times negative 2 minus 1. Okay, so negative 2 squared is 4. And so I've got, this is 8. 2 times 4 is 8. And 8 times negative 2 is negative 16 minus 1. And that looks like it's going to simplify to 8. Minus 16 would be negative 8. Minus 1 would be negative 9. So y equals negative 9. So my vertex would be negative 2, negative 9. Okay, that's my vertex. Let's talk about minimum and maximum values. And again, that would be the vertex. The maximum value is the y value of a, this is a frowny face. This is a negative parabola. This is a positive parabola. So this is a positive. So we think of positive as pluses, and we think of it as a smile, and negative parabolas will end up in a frowny face, right? Frowny face, negative. Okay, and how do we know that? Well, if a is negative, so if my leading coefficient up here is a negative number right here, then we'll have a maximum value. I'll have a vertex on top, and if I have a positive a positive leading coefficient, then I'll have a minimum value because it's going to be look like a smiley face. Okay, so that's kind of important to remember. And So for this one, it says, tell whether the function f of x equals negative 4x squared minus 24x minus 19 has a minimum value or a maximum value. Well, we look at the leading coefficient. It's negative 4. So negative means sad. So this parabola is going to look something like that, which means it has a maximum value. Okay, so the first number is the maximum value. And then find the value. So we're going to do what we just did on the previous one. I'm going to find the axis of symmetry. So x equals the opposite of b over 2a. So x equals the opposite of negative 24 over 2 times negative 4. So it's going to be a negative number because negative 24 over negative 8 is a positive, right? So this is this negative 24 over negative 8 makes it 24 over 8, which makes this negative 3. So my axis of symmetry is negative 3, and then to find that maximum value, I'm going to have to just go ahead and plug in that negative 3 into x in the original equation. So negative 4 times negative 3 squared minus 24 times negative 3 minus 19. Okay, so negative 4 times 9 minus 24 times negative 3 minus 19. Okay, so this is multiplying is negative 36. And this is a positive 24 times 3, I think it's 72. 72. That's going to be a positive 72 minus 19. And all this simplifies to 72 minus 36 minus 19, 17. So that maximum value is 17. Maximum value is 17. Okay, so that answers the question. But just like we did before, we're just finding the vertex, finding that line of symmetry, and then using that line of symmetry to find that maximum, in this case, that maximum value of 17, which is just the y value of my vertex, right? Okay, so now we're going to graph, and we're going to describe domain and range. So a couple things we can do here. A couple things we're going to recognize here. Let's first find the line of symmetry. Okay, so x equals the opposite of b over 2a. So x equals the opposite of negative 6 over 2 times 3. So x is going to equal, this is a negative, this is the opposite of a negative value, so this is going to be a positive 6 divided by 6, a positive 1. Okay, so this is a positive 1, and it's going to look something like, let's see if I can do this here with the proper things here. I think it should look something like this. Okay, so positive 1. It's close enough. Now, we want to find our vertex. So the vertex is 3 times 1 squared minus 6 times 1 plus 5. So 1 squared is just 1, so 3 times 1 is 3, minus 6 times 1 is 6, plus 5. So 3 minus 6 is negative 3. Negative 3 plus 5 is 2. So my vertex is at 1, 2. Okay, so I think this is my 1, 2. Okay, and according to the original, This is a positive parabola, so this is going to be a minimum, right? This is a minimum. So my graph is going to be up here somewhere. Now the next thing we can look at then is this number here, 5. This is the y-intercept, because the y-intercept is the value of y when x equals 0. So if x is 0, this term becomes 0, this term becomes 0, and I get left with a 5 here. Okay. Now one thing we know about parabolas is that they're symmetric. They're symmetric around an axis. This is my line of symmetry, so if I have a point here at 0, 5, I'll have a point over here at 2, 5. Okay, and then that's enough because I don't have any other point. I can't graph up here. So we're going to sketch a line through here. Boom. And it looks something like that. That's my sketch of my graph. Okay, so line of symmetry in the vertex, my y-intercept, and a point symmetric to the y-intercept. If this were going the other way, we might find y-intercept. We might find x-intercepts as well, depending on the graph. But this one's very thin because it's being stretched by 3 here, right? So it's very thin. So I can't I can't graph without making it go real tall, real fast. Okay, that's it for now. I'll see you in class next time. Have a great rest of your day.